The CIA built a ship to steal an entire Soviet submarine off the ocean floor and told the world it was mining rocks. The target was a nuclear-armed Soviet submarine, lost 3 miles down since March 1968, carrying missiles, codes, and secrets no spy could ever deliver. They called it Project Azorian. It cost $800 million. And when the moment finally came, something snapped. On March 8, 1968, a Soviet Golf II-class submarine called K-129 vanished in the vast North Pacific. 98 men and 3 nuclear-tipped ballistic missiles disappeared with it, somewhere more than 1,500 miles northwest of Hawaii. The U.S. Navy's underwater microphones picked up a muffled explosion. Acoustic triangulation, confirmed by the logs of the submarine USS Halibut, narrowed the wreck's position to a patch of seafloor nearly 16,500 feet down. The Soviets never recovered their boat. For American intelligence, the loss was more than a distant tragedy. It was a rare chance to reach inside the Soviet nuclear arsenal. Inside K-129 lay cryptographic equipment, missile guidance systems, and codebooks that could unlock Soviet secrets. But nothing at that depth had ever been salvaged. The CIA's Directorate of Science and Technology, led by figures known only in declassified files as Mr. P, saw both risk and opportunity. The agency's solution was to create a cover story so outlandish it might just be believed. A civilian mining expedition backed by the reclusive billionaire Howard Hughes. Hughes's Summa Corporation and Global Marine Development were contracted to build a ship unlike any before it. The public would hear about a mission to collect manganese nodules from the abyssal plain, an emerging frontier in ocean mining. In reality, every clause in the Summa contract and every bolt on the new vessel was designed for a single secret purpose: to lift a Soviet submarine off the ocean floor without the world suspecting a thing. The mining story, repeated in press releases and legal filings, kept Congress and the public at bay while the CIA funneled funds into the most ambitious covert engineering project of the Cold War. Authorization for Project Azorian did not arrive with fanfare or public debate. The decision moved through a narrow corridor of classified memos, each stamped with the highest secrecy. Inside the CIA, a select group of finance officers and senior leaders, known in files only by initials and code names, constructed the financial backbone for what would become the most expensive covert operation of its era. The project received its internal title, Azorian. Approval required more than a signature. The Deputy Director for Operations and the Director of Central Intelligence reviewed the plan, weighing the risks and the potential intelligence windfall. The final green light came from the 40 Committee, a secret interagency panel responsible for the most sensitive U.S. covert actions. Their authorization appeared in a 1974 memo, alongside an initial appropriation of $350 million, already an unprecedented sum for a single intelligence mission. But as engineering challenges multiplied, so did the costs. By the time the Hughes Glomar Explorer neared completion, the classified budget line for Azorian had grown to approximately $800 million. This figure, buried in CYA ledgers and confirmed in later audits, covered not only the construction of the ship and its custom-built lifting system, but also the elaborate legal and corporate machinery needed to keep the operation hidden. The money flowed through front companies and shell contracts, with Howard Hughes's Summa Corporation providing the perfect civilian mask. Few outside the CIA's Directorate of Science and Technology ever saw the full picture. For the handful who did, the numbers told their own story. The United States was willing to spend nearly $1 billion in 1974 currency for a shot at Soviet secrets lying 3 miles beneath the Pacific. The mandate was clear. The machinery would be built no matter the cost. At 16,500 feet, the Pacific is a world of darkness and crushing pressure. The navigation team faced the first technical test, pinpointing a lost Soviet submarine on a flat, featureless seabed. Engineers deployed a grid of acoustic beacons, each transponder anchored and calibrated by precise coordinates, forming an invisible map across miles of abyssal plain. The Hughes Glomar Explorer hovered above, relying on a network of thrusters and a dynamic positioning system to maintain its place within a margin of just a few meters. Even the slightest drift could spell disaster for the recovery. Station keeping was relentless work, with the bridge crew monitoring every current, every change in the ship's orientation, while sonar technicians listened for the faint echoes that would confirm the wreck's exact location. Only after a series of methodical sweeps did the instruments lock onto the target, marking the point where engineering would meet the unknown. 5,000 meters of pipe, each joint forged from miraging steel, formed the lifeline between the surface and the abyss. Every section was tested to withstand the pressure at 16,500 feet. The ISO-P full-scale pipe test confirming the pipe's ability to bear both static and dynamic forces. At the far end of this vertical bridge hung the capture vehicle, a hydraulic claw engineered for a working load of 8.5 million pounds, as documented in Declassified CIA records. The claw's articulated jaws could encircle and grip a submarine hull, transferring the entire mass through the riser to the ship's winch system. Structural engineers spent months refining the claw's geometry, calibrating the hydraulic actuators and stress points to survive not just the weight, but the unpredictable surges of the Pacific. On deck, the challenge was no less daunting. Each riser joint had to be lowered, aligned, and locked under the watchful eyes of the handling crew, who knew that a single misstep could jeopardize the entire mission. This was engineering at the edge of human capability, a mechanical gamble played out in silence and steel. Beneath the deck of the Glomar Explorer, the heart of the operation took shape, a 65-foot wide moon pool sealed from the open Pacific by massive steel gates. Through this circular well, the crew could lower and raise the entire pipe string and capture vehicle, shielded from the chaos of wind and waves. At the surface, a gimbaled platform kept the lift perfectly vertical, even as the ship rocked above. Deck chiefs and engineers worked in constant coordination, overseeing every joint, every bolt, and every cable. The winch system, designed to handle up to 14 million pounds, could haul the combined weight of the riser, claw, and submarine section with a margin for the unpredictable surges of the sea. Heave compensation gear, built into the gimbal, absorbed the ship's motion, sparing the fragile connections below from sudden shock. In these moments, the surface crew became the final link in a chain of engineering decisions, their focus and discipline holding the entire mission together. In June 1974, the Hughes Glomar Explorer slipped away from San Pedro, California, her hull stretching 619 feet from bow to stern. The ship's bulk dwarfed most vessels in the harbor, and every inch of her design spoke to a purpose hidden behind the official story of deep-sea mining. On board, a crew of roughly 140 deckhands, engineers, and specialists prepared for the most ambitious lift ever attempted at sea. The departure logs recorded a calm morning, but tension ran just beneath the surface. Months of sea trials had exposed every flaw, every creak in the moon pool gates, every hesitation in the hydraulic winches. Now, with the Pacific rolling out ahead, all eyes turned to the horizon and the coordinates that would define their mission. The deck chiefs barked orders as riser joints were staged for assembly. Each segment of miraging steel pipe was craned into position, then locked and checked for hairline cracks. Below, the moon pool yawned open, a 65-foot wide shaft that would become the gateway to the abyss. The crew moved with practiced caution, their routines honed by weeks of drills, but shadowed by the knowledge that no one had ever tried to haul such a weight from 3 miles beneath the sea. The ship's dynamic positioning system hummed, keeping the Glomar Explorer fixed within a margin of meters above the target site. Every calculation, every checklist, every glance between the men on deck carried the weight of what was about to unfold. The ship was in position. The capture vehicle waited at the end of 5,000 meters of pipe. The lift window had opened. The strain gauge numbers climbed with every foot of ascent. The digits on the main readout flickered between 9 and 10 million pounds. Then, without warning, the load spiked. The bridge alarm shrieked. 12 million pounds. The captain shouted for an immediate stop, but the surge had already pushed the steel beyond its limit. In the next instant, the pipe snapped with a sound sharp later compared to a cannon blast. For a split second, everything froze. The crew heard the echo ring through the hull as the fracture ripped through the riser just above the gimbal. In his memoir, David Sharp recalled, "When the claw finally gave, the entire load slammed into the wellhead like a freight train hitting a brick wall. I could hear the buckling steel, and I thought, we've just lost the prize." The overload had been sudden, the result of a hydraulic surge and a flaw at the weld line, a perfect storm of metal fatigue and pressure. The winch alarms still screamed as the claw and the captured submarine section plunged back into the darkness. On deck, men stared at the empty moon pool, silent. The dream of lifting a Soviet missile boat from 3 miles down had vanished in a single, irreversible moment. The Glomar Explorer sits idle now, but its legacy shapes every classified mission. Intelligence stakes have only grown, and secrecy endures, shielded by the same neither confirm nor deny. In this era of invisible warfare, the boundary between what is hidden and what is revealed remains as deep as the ocean floor. Share your thoughts below.